It's too many buttons, too many buttons. So welcome. My name is Ann Merchant, and we are very glad that you are here with us today for our event, which we're calling Heat Season, Climate Change's Latest Curveball. And Rick, that was super sad music that you picked for the slide deck today, I have to say.
Yeah, it did play a little bit like that, those we lost scroll from news programs. So sorry for that. We didn't mean to be quite that somber opening.
No, but I am glad that, the curveball, it's not an exchange curveball. I would be sad if you were not here with me today. So of course you need to introduce yourself for
Oh
those of
yes,
you who do not know.
I'm Rick Lovett. I am the program director of the Science and Entertainment Exchange, which is a program of the National Academy of Sciences. That makes Ann Merchant my boss.
And not that that's the relationship you usually admit to, but I am glad that we are here doing this with our audience once again. And I think for as long as I've worked for the Academy, we have been producing reports on climate change, but of course our portfolio on this topic extends well beyond my tenure. I think the first report that we did on climate change was in the 1970s, and I have not worked for the Academy that long. And so this has been an archive to which we have steadily been adding for a number of decades. It's certainly no surprise to scientists that the impact of climate change are becoming more pronounced. I think, though, that in recent months, we've certainly seen that the droughts, the fires, and the severe heat wave that has been all over the news, that these have managed to create astounding consequences. So today's conversation, I think, will provide some new insights into this alarming topic. But I also think, Kate Marvel, who is our climate scientist and is with us today, as she has said, she is an optimist. And I think that many climate scientists, interestingly, are optimists. And so we'll also have a side of this conversation that I think will make us feel that this is not an inevitable future for us or for our planet. And of course, Hollywood always loves a good disaster scenario, and planetary doom is something where movies and television often start. But even Hollywood doesn't like to take us down the ending where we can't get out of it. And so all is never lost. And I think that's why this is an interesting topic from the exchange's point of view.
Yeah, that's right. We get a lot of calls about climate change and a lot of calls about climate change as it pertains to disaster. I think historically, this is a difficult subject to dramatize. And there are a lot of different reasons for that hopefully they'll touch on today. But if you are a storyteller and you're just hearing about this, we've done over 3,300 consultations since we opened our doors in 2008. So if you have a question about science, engineering, medicine, mathematics, give us a call and we will connect you to someone who knows what they're talking about to answer your question. And, if you are a STEM professional and you're just joining our audience for the first time and you're like, what is this thing that's connecting people like me to storytellers? Please also give us a call. We would love to hear from you. We have a volunteer database of about 3,000 STEM professionals from which we draw on a daily basis. So I want to thank today's sponsor, in particular, HHMI, without whose support we could not be doing these events. We also get major funding from the Alfred P. Sloan Foundation, many other foundational institutional donors who you saw on the slide, and individual donors like you. Many of you gave for this event today, and we thank you. If you gave at the supporter level, we will be sending you one of these, which I've been a little bit slow to get out, and that is my fault, and I am sorry. They will be coming to you soon. So a little bit about the event structure today, a little looser than maybe some of the other events. I think Kate Marvel will be starting with a few words, and then it's going to be much more in conversation, a lot more conversational. So if you have a question down here or up here, depending on how you are watching, there should be a little bubble that says Q&A. Please ask your question at any time. I'll be behind the scenes fielding those questions, sending them to Cate Adams. If your question does not get answered, it is because of me. It is not because of Cate Adams. But we're going to get to as many of your questions as humanly possible today. So please feel free to ask a question. I want to thank Ameche, Courtney, Sachi, and Jeff, our team in DC and LA, for making these events possible, because Ann and I are not very technical people. We would have no idea how to make this happen without you guys. And should I go right to the rabbit hole or back to you, Ann?
No, do the rabbit hole.
So the thing that I got lost in as I was thinking about climate change and heat season this time is actually a little bit self-serving, not gonna lie. One of our retreat alums, we do these retreats, these very fancy retreats where we bring together high-level filmmakers, high-level scientists, and this was of course pre-pandemic, but one of our alums from that whole engagement is a guy named Ben Von Wong, who's gone on, at the time, even when we met him, he was doing some interesting stuff, but he's gone on to do some really interesting art, making statements about climate and climate change. And I would encourage you all to check out this site because there are some really beautiful images on it.
Yeah, exactly. And we're a big fan of Ben and Ben's work. So my rabbit hole was a National Geographic climate simulator. I think it's called See How Your City's Climate Might Change by 2070. And so it compares your city to current conditions in another city. So by 2070, Boston will feel like Bardwell, Texas does today, where it's 8 degrees hotter than Boston and gets 2 inches more rain every year. And then there's a place like Hanoi in Vietnam, which will feel like nowhere currently on the planet because there is no direct comparison to anywhere that currently exists in the world, which is apparently true of 90 cities on the planet. So you can use the simulator to look at your city and compare it to another city location, and you can spend a lot of time doing that, which I did. So that's my rabbit hole. And I think Sachi is putting a link in the chat if you want to go down that rabbit hole. But of course, the rabbit hole that we offer you for the next hour is our 2 speakers. And as Rick said, we have 2 Kates, not just one, but 2, but with a different starting letter, so you can distinguish between them. And actually, when you talked about our retreats, Rick, so both Kate met one another at one of the retreats that we did. And what was interesting, we had, as Rick said, a wonderful lineup of scientists. And then we have sort of an open Q&A session. We don't do Q&A after each scientist gives a talk because that in itself is a bit of a rabbit hole. But after each of the blocks of time that we set aside for these open Q&As, Kate Marvel received more questions than any of the other scientists because everyone wanted to return to the very compelling topic of climate change. And I think that, she was just peppered with so many questions. And so we thought we really need to have her back on our stage. And we know that Cate Adams was one of the people peppering her with questions. So we've given them the opportunity to do this, just the 2 of them. So Kate Marvel, we're going to give you the floor now and invite you to turn on your camera. And if you hear some background noise, it's because she does have her air conditioning on and we are not going to ask her to turn it on, not in heat season.
All right, thank you so much. I want to clarify, it is not an air conditioning, it is a fan. I am not fortunate enough to have air conditioning here. So hi everybody, my name is Kate Marvel and I am a climate scientist at Columbia University and the NASA Goddard Institute for Space Studies. I think the number one thing about climate change that I have been accustomed to saying is that we're not making it up. But I think now we're moving into a new regime where the impacts of climate change are so large and so undeniable that it's really, really hard to keep maintaining that all of the scientists in the world have come together and are perpetuating a massive hoax. Trust me, if I was going to be in charge of a giant hoax, we would be having a lot more fun. So there are a couple of things that I want to say about climate change before we really get started with the conversation. The first is that it's real. The second is that it's us. Human activities, specifically emission of greenhouse gases like carbon dioxide, but also methane, nitrous oxide. Our emission of greenhouse gases are responsible for all of the global warming that we see. In fact, they're responsible for a little bit more than all of it because natural factors would be ever so slightly cooling the world. So that's something that I think a lot of people don't really appreciate. The warming that we've seen, it is all due to us. So how much warming have we seen? Well, so far we've seen about 1 degree Celsius of warming above pre-industrial. And that's because we have increased carbon dioxide in the atmosphere by about 50% since the Industrial Revolution. And one of the questions that I get asked most frequently now is, or I used to get asked most frequently is, okay, but who cares? And that is a reasonable question. because nobody actually experiences the average temperature of the planet. Especially, I live in New York City. In the winter in New York, a couple degrees of warming can sometimes seem like a really good idea. But the reason that we care about climate change is that climate change affects everything. It affects the world that we live in. And one of the ways that we see those effects is through extreme weather. So we know that on a hotter planet, there are more extreme and more frequent heat waves. That's something where the physics are incredibly solid. We also know that there are more frequent and heavier downpours in a warming world. And that's because warm air holds more water vapor. It holds about 7% more water vapor per degree Celsius of warming. So that means that there is more water that the atmosphere can dump on us. And that means that certain extreme events like Hurricane Harvey, that crazy downpour that got dumped on Houston, that wouldn't have been possible without climate change. But at the same time, we know that climate change will probably give us more floods, more intense downpours, but it will also give us more droughts. And that's because that water vapor in the atmosphere is coming from somewhere. Warm air is thirstier air, and it's slurping up more air from the land surface. So even if there are no changes to precipitation patterns in the future, we could still expect more frequent droughts because that air is thirstier, it's sucking more moisture away from the surface. We know that warm waters are hurricane food, so we expect to see not necessarily more hurricanes in the future, but we expect to see more stronger hurricanes in the future, more of those category 4 and 5 hurricanes. So a lot of times people say, would this have been possible without climate change? Or what are the odds of this particular extreme event, this heat wave, this flood, this downpour? What are the odds of climate change? And that's a question that we can actually answer. But that strikes me as kind of the wrong question. The way that I think about climate change and extreme events is the way that I think about somebody like, not to pick on him, but Lance Armstrong. So when we find out that a sports figure has been using banned substances, has been doping, we don't go back and say, okay, well, if he wasn't using those banned substances, I think he would have come 3rd in that race and 17th in that race and 34th in that race. And that one he probably would have won anyway. We don't do that. We say, hey, we know what doping does, and we know he was doping. So we feel justified in taking action. And climate change is like doping the weather. We know what carbon dioxide does, we know what greenhouse gases do, and we know what those rising temperatures mean. There's still a lot of uncertainties, but underlying that is some really, really clear physics, stuff that we have understood since the late 1800s. A lot of this is not new science. So I think that's probably enough for me. I'm really, really excited to be in conversation with Cate with a C today. So I will invite her to turn on her camera and microphone.
Hello. It's always nice
Hello.
to meet a fellow Cate. And I'm very excited to chat with you today. I have a series of questions. I know the audience probably has many, many questions, and hopefully we will get to as many as possible. I will admit that when Anne mentioned her rabbit hole and discussed Hanoi and said we don't know what it's going to be, I thought it was because Hanoi wouldn't exist. And because just in that general sense of, we know that coastal areas are potentially most at risk of suffering from climate change disasters. And I think one of the popular news phrases that we used to hear was about climate safe cities or climate safe locations. And this year in particular, I feel like we're seeing those places that we thought were climate safe, the Pacific Northwest or Chicago or even London, experiencing extreme heat waves. My sister lives in Salem, Oregon, and it was as hot there, 117 degrees, as it was in Las Vegas, Nevada. So I'm curious, what do you respond to climate safe cities? Are there any?
I think your point is really interesting because it really illustrates the fact that to be a climate safe city or a climate safer city, that's not necessarily just a function of where you are located. That's a function of how well you take care of your citizens. That's a function of your government capacity. That's a function of who is making the decisions and how represented people are. So you're absolutely right that a place that may have thought that it was safe from sea level rise is not going to be safe from wildfire smoke. It's not going to be safe from downpours or droughts. So the fact that the Earth system is incredibly complex and we are kicking it extremely hard. There's never been an experiment like this done in the whole history of the planet. So this is not really something that we have a control group for. There is a lot that can and is going wrong. And I will not say you should go live somewhere and you will definitely be safe, because nowhere is safe. But the way that we make places safer is we make them better places to live. We make them more responsive to their citizens.
Good note to have. I will say, I think we talk a lot about warming and global warming and droughts, and people then have a response that, like, we need global warming. I just remember hearing that phrase from some members of the right when Texas had their cold snap. And do we see those freakish moments, those cold snaps, those unexpected events happening more frequently from your perspective? And do scientists know how to predict them, or we can't predict them because they're, as you said, it's an experiment that's never been done before?
So we see more extreme heat records being broken than extreme cold records. But winter is a phenomenon that is known to science. We are aware of it. And so winter is not going to go away. There still is going to be weather. There's still going to be cold snaps. The case of things like Texas and that deep freeze and that really, really wild, weird weather in the winter is really interesting for me, because that is an example of one of those really, really rare aspects of climate science where there is a genuine scientific debate. Some folks say climate change is making the jet stream wonky. It's making it wiggly, and that means that cold air is more able to come down from the Arctic and cause chaos in the mid-latitudes where we live. And then that is not a bad hypothesis whatsoever. But then there's other scientists who say, I'm not convinced yet. I don't really see the evidence for this. So something like the wiggliness of the jet stream and that wild weather, that is an example of something where scientists are still debating.
I think debate is so clearly a frequent occurrence nowadays, and also, as evidenced by science, it's constantly changing because you're constantly challenging yourselves and questioning yourselves and looking at the evidence and making hypotheses accordingly. I want to go back to when you talk about making cities and people responsible for making their own cities safe. And I guess as trying to be a socially responsible citizen of planet Earth, I think a lot, and I think a lot of people think a lot about what we can do as people to make changes. And it's like you Google a list of things that you can do to help climate change, and it's like, eat less meat, travel on public transportation. Some more extreme ones tell you to get rid of your pets. I'm curious what you would say to people that are like, what can I do? What can we do?
Yeah, so I am a bad person to ask life advice of, because I'm a physicist. I study water molecules and little parcels of air. I don't study people. But I do know that there are limits to individual actions. Definitely, if you want to reduce your personal carbon footprint, there's ways to do that. You can switch, if you own your home, you can switch to using solar or wind energy. You can eat a plant-based diet. But we've had a particularly brutal demonstration over the past year of the limits of individual action, because the world economy basically shut down because of COVID. And that led to a 7% reduction in global greenhouse gas emissions. And to put that in context, in order to stay below certain limits defined as safe limits, they're not safe, but in order to stay below 2 degrees of global warming, we would need to do a 7% reduction in emissions every year. that's clearly something that is not going to be achievable by individuals choosing to live more virtuous lives. And in fact, the thing that blows my mind is that the concept of the individual personal carbon footprint was invented in 2004 by BP. Because if you can create the impression that this is an individual problem, that people can simply choose their way out of it, then you avoid systemic action. You avoid regulation of your company. So I think that's something to keep in perspective. Climate action is going to require really, really large scale social action. It's going to require government action. It's going to require policy. Individual choices are important, and I am not denigrating them, but they are nowhere near enough.
So in theory, if we can't do it alone, we all have to do it together, which means, to my mind, pushing policy and pushing politicians. And so are there policies that you're a particular fan of, not necessarily endorsing people, but like, what is the Green New Deal a good one? Should we be advocating everybody to support that? What, I mean, what's your recommendation there?
So from my perspective as a physicist, the way you stop climate change is stop putting greenhouse gases in the atmosphere. I am not a policy professional, so I don't necessarily feel qualified to judge what is the best way to not do that. I'm really gratified that we seem to be moving into having debates about policies, as opposed to debates about, is it real? Did you guys make all of this up? So I think that is really useful. My goal is to be completely irrelevant to the climate discussion, because we're having debates about what we should be doing about it and what the fastest way to draw down greenhouse gas emissions is, rather than is this something that's happening. I think for a really long time, the failure of climate action has really been a failure of storytelling. And I'd love to get your perspective on that, because I think for so long we've been told a certain set of stories about climate change. Either here's this polar bear is dying, it is your fault personally, you're a bad person. I don't like that story. And then you try to introduce some conflict in it. So these scientists all say climate change is happening, but this guy says it's not. Who's right? And now I think there's a story that's creeping in, which is the story of inevitable doom. Humans are terrible, humans are bad, this is punishment, there's nothing we can do about this, the world's gonna burn. And that story is not supported by the science, but it seems to be a story that's popular nonetheless. And so I'm wondering what your perspective on climate storytelling is. Why is this story so hard to tell?
I think there's a couple different things, which is that as much as we like to shape stories to help change people's perspective and give people something to think about, I am also a film executive who works in the entertainment business, and I think about those two words every time I'm telling a story. Is it entertaining, and is it business, i.e. rather crassly, can I make money from it? So I think what happens with the more realistic storytelling about climate change is that it may or may not have what I like to call enough peanut butter. It's too much pill. So it's how do we create a character, or how do we create a storyline wherein the people are excited about it, and climate change is just kind of like present, but not necessarily, the movie's not about climate change. It's not about what's happening. It's just that is a factor in everyone's lives. Or if it's a character that is a rom-com with a character who is interested in, climate change and how we help it. We continue to strive to do that work, but I think what's hard about anything, when it feels like a messagey movie or a messagey television show, people don't tune in, which means that we don't make money, which means that we don't make more of those types of stories. I feel like I had one more question. but I don't want to, I'm going to skip it because I don't like it. So I'm going to go to some of the crowd questions. One, I have two that are interesting in terms of how they talk about the degree temperature raises in CO2 emissions. So Michael asks, if all CO2 emissions magically stopped today, how long would it take for the Earth to mitigate the effects of climate change? Michael, you're living in a hopeful fantasy world that I also want to live in. But Cate, how long would it take to mitigate these effects?
Yeah, it's a great question. So if we all magically stopped carbon dioxide emissions tomorrow, I would be really excited. I would be really happy. But there would be a few complicating factors there. The first is that there's a carbon cycle. So we're all living things rely on carbon. Carbon flows through our bodies and the bodies of all living things. We exhale carbon dioxide, plants take in carbon dioxide, everything is in balance. We have, as humans, not us personally, but human beings, have disturbed that balance by digging up carbon that is locked in fossil fuels and setting that on fire and putting that into the atmosphere. Now, if we stopped doing that, there's uncertainty in exactly how long it would take the carbon cycle to adjust, exactly how long it would take the trees and the plants on land and the phytoplankton in the ocean to draw down that carbon dioxide in the atmosphere. But I think the take-home message is that stopping emissions is a great idea. And if we do that, there are small complications, but stopping emissions will basically stop climate change.
If only. I dream that dream. Olga asks, what does a 1 degree average, I'll go with increase, mean for polar regions?
We're living in it right now. So we live in a world that is 1 degree Celsius warmer, a little bit more than it was before the Industrial Revolution. And the Arctic is really kind of the canary in the coal mine for climate change, because the Arctic is warming faster than any region on the planet. There are several reasons for this, but basically it's because the Arctic is covered in ice. And when you make it really warm, what happens to that ice? You melt it. And that gives rise to a feedback loop where you used to have ice that was really shiny, that was reflecting all of the sunlight. And now you have taken away that ice and replaced it with something darker underneath. And when you do that, the land or the ocean is more absorbent. And so the warming accelerates. So that's an example of a destabilizing feedback loop. And that is happening in the Arctic right now. So the state of the Arctic right now, some of these really pronounced heat waves in the Arctic are indicative of climate change, and they are what happens in a world that is 1 degree warmer.
I imagine that is not only bad for the carbon loop and the climate cycle, but also the interconnectedness of species that are living in that area, and thus how they're affected, and then where they start traveling or not traveling or becoming extinct because of it. And we have a question sort of related to that, which Elva asks, as I understand it, saving whales could be more important than saving trees in terms of impacting climate change. Is this true?
Why not both? You know, I am pro whale, I am pro tree. Because whales are not just extremely useful in the ocean ecosystem in and of themselves, but a healthy whale population is indicative of a healthy ocean ecosystem. We know that the ocean is vital for climate solutions. Thing covers 70% of the Earth's surface, and produces most of the oxygen, or half of the oxygen that we breathe. So a healthy ocean and ocean-based climate solutions are really, really important for eventual climate solutions. Trees, I don't want to knock trees. I think trees are great. I think it's really important to note, though, that we cannot plant our way out of climate change. Planting 1 trillion trees and carrying on with business as usual is not going to solve the climate crisis. And that's because trees are really complicated. Yes, trees take in carbon dioxide, and that's great. But when trees die, that carbon is put back into the soil or into the atmosphere. So trees are part of a carbon cycle. We also know that if you've got land that is forested, that has a different shininess, a different albedo than other land covered in grassland or ice or some other substance. So the point that I want to make here is A, I am extremely pro-rail and pro-tree, but B, the climate system is incredibly complex, and we can anticipate some knock-on effects, but it is really, really difficult to anticipate all of the effects that come with poking even a small part of that system.
That just made me think of two things. One was an article about how in the Pacific Northwest, all of the mussels are basically beached and dead because they boiled alive on the sands. And I can't imagine the delicate balance that happens in the ocean being so affected by that. We don't even know the consequences yet of all that death is. And then separately, you said we can't plant our way out of this, which makes me think of the fact that even though we talk about in the industry responsibility and needing for policy change, I'm curious what your thoughts are about the people who are like, oh, I will pay for like mending my carbon footprint, because there are companies now that pay to counteract like how many plane trips you take, and like, are they doing any good, these companies, or should we be spending our money elsewhere?
My view, so I am, again, this is my temperament. I'm not a Puritan. I am very pro-fun, and I think we should have fun and we should experience joy. So I don't want to tell people not to do things that they find fun. I think, business as usual plus carbon offsets is not going to cut it. But what I would really prefer is, instead of saying, okay, I'm going to fly 15 times a year for work and I'm going to offset all of those, what if you spoke to your boss, or if you are the boss, what if you thought about, are those trips really necessary? Could we replace those trips with something else? And if you change the structures, if you change the incentives, so that maybe you're not taking 0 flights a year, but you have the number of flights you take, or you divide them by 3 or whatever, then I think that is much more meaningful. I think there's a tendency to be really negative about carbon offsets, and I think there are some bad actors in the market. But at the same time, there are certain things that are extremely difficult to decarbonize. Aviation is one of them. Aviation is responsible for about 3%, 4% of global warming. And that's something that is really difficult given current technology to decarbonize. So that is a candidate for something like carbon offsets. But I think most other scientists, we know that the atmosphere just cares about how much carbon dioxide goes in there. Ultimately, that's the thing that matters.
I know you mentioned 2 other gases. Roy asked whether some other gases that have big impacts on climate change besides carbon dioxide. I know you mentioned methane and nitrous oxide. Are there any others that we're putting out that we need to try to reduce?
I mean, those are the biggies. I want to take this opportunity to talk about what we think of as pollution. We don't often think about carbon dioxide as pollution because it's colorless and it's odorless and we all breathe it out, but it very much is. But I'm talking about the pollution that we all recognize as pollution, particulate matter, sort of that gas and dust and kind of filth that goes into the atmosphere. Scientists call those little tiny particles aerosols. And those emissions are generated by the same things that are generating carbon dioxide emissions. It's really complex, though, because those little particles, those bits of gas and dust, they tend to have a cooling effect on the planet because they essentially block the sun. And so that goes into how complex it is to understand this climate system. Obviously, those aerosol emissions, that gas and dust, it doesn't block enough sun to counteract the warming that's induced by greenhouse gases. And they are terrible for human health. We've seen a real reduction in those aerosol emissions, especially in North America and Western Europe after the Clean Air Acts of the 1970s, 1980s. And that is a good thing. That is a wonderful thing for human health. But at the same time, following that clean air legislation, we see global temperatures start to rise even more. And that's because we've taken away that sort of partially mitigating effect of the aerosols.
Nothing's easy. It's just so complicated. It is so complicated. Because two people asked this, and I think it is an interesting distinction, if there is a distinction, is what do you think of the terms climate change and global warming, and are they interchangeable?
I don't care. The way that I view it as a scientist is we are putting carbon dioxide in the atmosphere, the temperature is getting warmer, the climate is changing, and stuff's getting weird. So I think there's this tendency that, okay, well, if we just call it something different, we're going to solve the climate crisis. Like, call it the climate emergency, call it the crisis, call it global warming. Don't call it. It's as a physical scientist, I don't care, and I'm also not qualified to sort of judge the impact of those different terms.
I think that's the marketing executives among us would probably be more helpful to what the most effective phrase would be, similar to BP creating personal climate responsibility, which I find horrifying. So Ben Simpson asked, does the Gulf of Mexico catching on fire speak to ways in which huge corporations have more impact on climate change than my own personal decisions, like using a plastic straw?
Yes, I would totally watch a movie where Jason Statham punches a bunch of fossil fuel executives. I think free idea, please make that movie. But yeah, I think, again, like, individual climate actions are important insofar as they build credibility, insofar as they keep people engaged, and insofar as they create new models for what a happy, fulfilled life might look like. But I do think it is really important to note that the vast majority of emissions come from 70 different companies. 70% of emissions come from 100 companies. Sorry about that. And obviously, those companies would say, well, we're making products that you people use. It is your responsibility. And there's no easy answers here. But I think it is the thing that I hold on to is that we don't need technological breakthroughs to solve climate change. We have most of the technology that we need already.
I'm curious, when you say we have it, what are the big ones? What are the big things that we should be getting politicians and policymakers or even CEOs to support?
There's the thing about climate change is that its impacts are incredibly multifaceted, but its causes are also multifaceted. So there's no one silver bullet for climate change. I actually hate that metaphor. Like, why do we have to shoot everything? But climate change is caused by emissions, and those emissions in the US are about the contribution from the electricity sector and the contribution from transportation are roughly equal right now. So what that means is that if we, move the electricity system to renewables, so wind, solar, hydro, I am personally reluctantly pro-nuclear. I think there's debate about nuclear, but it does not generate carbon dioxide in the generation of energy. So if we move to those technologies that we already have, so decarbonize the electricity system, and B, electrify everything, electrify transport, that is going to make a huge dent in climate change, a huge dent in emissions. We have the technologies, wind and solar. We need to decarbonize most of the electricity system. And in fact, those technologies are the cheapest way of generating electricity right now.
I'm curious, because when we talk about when you say electrify everything, I immediately think of electric vehicles and their batteries, and then my mind goes to rare earth materials. And are we putting ourselves at further risk, or is the risk from digging up rare earth materials and using those so much less than continuing to release carbon into the atmosphere that it's worth that?
Yeah, I think there's no free energy, right? There's always going to be considerations, and there's always going to be drawbacks of any energy source that we use. And it's really, really important to keep that in mind moving forward. So that means things like efficiency savings are extremely important. We just simply using less energy to do the same thing. That's low-hanging fruit. That's stuff that is one of the few win-win situations in life, is energy efficiency. So that's very important as well. But it's true that no source of energy is going to be completely consequence-free. If you build large-scale wind turbines, there's some evidence that they can change the weather very, very slightly if there are a lot of them in a particular location. They also make Kennedys very, very angry. They don't like seeing them off Cape Cod, so that might be a drawback. Solar panels, cheap, efficient, right now fairly hard to keep clean, and there's some countries like the UK, like Denmark, that aren't really that sunny all the time. So I'm not minimizing the scale of what needs to be done, and I'm not saying that wind and solar are going to be the single greatest solution. But I do know that all energy on the planet, or 99.99% of the energy except for nuclear reactions, comes from the sun. So all energy is solar energy. We can either directly capture it using solar panels, we can use it to boil water and drive turbines with the steam, we can wait until it blows wind around and capture that wind, or we can take plants and animals, let them capture that solar energy, let them die with that remnant of their last meal still in their stomach, wait millions of years, and then dig them up and set them on fire. Fossil fuels are just solar energy. And I think let's skip that step.
Michelle asks, how would you respond to experts and colleagues who are critical of the message that climate change will be as catastrophic as most scientists seem to believe it will be?
So I will push back on that. I think that unchecked climate change will be catastrophic. There's no doubt. But as a scientist who does these future climate projections, the biggest uncertainty, the biggest wild card is what human beings do. The biggest uncertainty is future emissions trajectories. We can't stop climate change. It's already here, it's already happening. But we can avoid these apocalyptic worst case scenarios. There is no reason that those need to happen. The atmosphere cares about the carbon dioxide that goes in it. And maybe you think, well, there's no way that human beings will actually do that because human nature is just fundamentally bad. And you're welcome to that opinion. But the science shows that it is still possible to avoid the worst of climate change.
So leaving the X factor, namely us, out of it, Chris asks, how accurate are our best climate change models, and how sensitive are they to small changes that may happen?
So that is an incredibly complex question because climate models generate hundreds of variables. They tell you changes in temperature, not just all over the globe, but changes in temperature in California and New York and over the ocean and Antarctica. They tell you changes in precipitation. They tell you humidity changes. They tell you changes in the wind speed. And so because climate models output so many different variables, saying, are they right? Are they accurate? That is a question that doesn't really make a lot of sense. Yes, climate models are wrong. All models are wrong. if you had a model which was a perfect way to capture absolutely everything that was going on the planet on a computer, that would be the matrix. We don't have that. That's creepy, and we don't want that. So all models are wrong. All models are a simplification of the real world. So we know that. The question is, are they useful? And yes, climate models are extremely useful. By a lot of different metrics, climate models have been excellent at capturing the large-scale warming that we've seen so far. The question then becomes, what can we expect climate models to do? So climate models are predicting changes in the average conditions over long timescales as a result of increases in carbon dioxide emissions. They're not weather models. It's not their job to predict weather. We want them to get the statistics right. So we want them to say heat waves will become more common in a way that they actually do become more common. But a climate model cannot say there should be a heat wave in the Pacific Northwest on June 26th. That's not what they're for. So I'm sorry, that's a really, really long-winded way of saying there are many, many different ways for climate models to be useful or not useful. But the preponderance of the evidence is that for most of the purposes we use them for, they're quite useful.
On the subject of models and a specific question, Tony asks, will heat waves in Western Europe become as severe as they have been in the Western US?
Great question. We do know that generally over the entire planet, as the average temperature increases, those tails of the probability distribution are getting shifted over as well, which means that we're going to see more events that used to be very, very rare. A thing about the recent Pacific Northwest heat wave is that heat wave is weird even in the context of climate change. So is that, to go back to the last question, is that perhaps an indicator that there's something that the climate models are not capturing? Or is that just, if the probability that something doesn't happen is 95%, it's going to happen 5% of the time. So we have to be really careful when we talk about these events to make sure that we actually get the statistics right.
I'm going to shift gears back to personal responsibility, as this is a topic that is on my personal mind, and also I know friends are considering it as well. Frank asks, do you think people should be having less children as part of their effort to mitigate climate change?
I am very, 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 I'm of a very strong opinion that how many kids somebody has is none of my business. We talk, some people like to talk about population as being the primary driver of climate change. And it's not the number of people, it's the emissions that those people generate. I think the history of population control, which is such a creepy word, is so polluted by essentially people of a certain demographic telling people of other demographics what to do with their bodies and what to do with their lives. And I think we can't address population concerns without acknowledging that history. I personally am extremely unhappy with telling anybody how to live their lives. And I also really like children, and I don't think it's a good message for children to hear that they should not have been born.
Hear, hear. Definitely, that is not something that any child should ever hear. I agree. Dan has a question for me, which is, what kind of TV show or cable series treatment would best lend itself to having climate messaging and information integrated into it? I'm not a TV exec, so I'm not an expert in terms of what lends itself to it, but what my recommendation would be as a fan of consumption in general and watching things and knowing what there is clear evidence that people change their behaviors based on popular shows, whether it's Nashville, the city that I'm from. Honestly, the population increased when the show Nashville came on and people thought it was a cool city to go to. CSI, there was a huge increase in people becoming crime scene investigators because that was a job that was evidenced. So I would say if you can get a basic cable show talking about climate change, whether it's Fox 911 shows that have emergency situations that are based on the fact that climate change is happening, and they may or may not mention that this freak hurricane fire is because of climate change. I think that's helpful to put into the minds of people, but I also think it's helpful to have kids shows that acknowledge climate change and get a whole new generation of people thinking about it. You know, if kids are acknowledging in Octonauts that a species is endangered because of climate change, then they just know that climate change is happening and someone needs to do something about it. So I think any show, every show, is my response to that. Going back to questions for Cate M, and Cate with a K. Anne, what is your opinion on the question of the jet stream having shifted? In other words, have we crossed a critical threshold that would make the heat dome over the Pacific Northwest a recurring event rather than an outlier?
So, I mean, that goes back to what I was talking about earlier, which is this theory of the wavy jet stream is really something where the jury is still out. You know, I think I will use that to sort of address this question more broadly of tipping points in the climate system. So we do run the danger of crossing a tipping point. And by a tipping point, I mean something where a small change can lead to a large and irreversible on our timescales change. Those include something like the breakup and melting of the Greenland and West Antarctic ice sheets. Again, we don't know very much about how those ice sheets melt and disintegrate because we've never done this experiment before. But that is something that is a fear. So we don't know what the threshold for that is. And you know, the scientific advice would be, well, don't play chicken with that. Don't step too close to that line. We don't know yet whether you know, the jet stream going wavy and this weird weather in the mid-latitudes is directly tied to climate change, but there's some theoretical reasons to believe that it might be.
There's so many questions now. I'm trying to get to all of them. I promise. I don't know that we will be able to. A couple people have asked what essentially like our current use of plastics and that impact on climate change. Is using plastics and single-use plastics bad? I mean, we know it's bad, but what I guess my question is like, how bad is it for climate?
In terms of climate, the thing, you know, in global average temperature, the thing that really matters is the emissions. And obviously, plastics are a byproduct of the fossil fuel industry. And so extracting and manufacturing those plastics releases carbon dioxide into the atmosphere. You know, obviously, we don't just care about the average temperature of the planet. We don't even just care about extreme weather events. We care about the overall health of the ecosystems. We care about biodiversity. And treating the atmosphere like an infinite dumpster for all of our emissions is a bad idea. And treating the ocean like an infinite dumpster for all of the plastic is also a bad idea.
Okay, I have time for two questions, I think. So I apologize. I will not get to all of them, but I'm going to ask some selfishly that are interesting to me. Can you speak on geoengineering, the ethics of it, possible downsides, benefits of it? And geoengineering is, I will give my brief understanding of it, are things like cloud seeding. So like putting something into the atmosphere, like shooting a chemical up that then creates more clouds and then rain to combat droughts.
Right. So there's a lot of theoretical sort of model-based research going on geoengineering right now. So you've got not just cloud seeding, but things like cloud brightening, which is making clouds over the ocean brighter so they theoretically reflect more sunlight and cool the planet. You've got proposals to directly inject particles in the stratosphere, which basically would act as planetary sunblock and block the sun and slow down warming that way. My sense is that those would probably work in the sense of they would reduce the global warming rate. But they, again, going back to this theme of knock-on effects, they would have really unpredictable effects. So if we continued to increase carbon dioxide, we didn't do anything to cut emissions, and at the same time, we did this geoengineering exercise where we blocked sunlight, there could be really large impacts on the hydrological cycle. We could shift rainfall patterns, and lots of things on the planet like sunlight. I like sunlight, plants really like sunlight, so there could be massive consequences that way. The thing that really scares me is that it almost doesn't matter if you can attribute a particular disaster or a particular weather event to geoengineering, as long as there is that perception. Because right now, the capability to do this, the capability to inject particles into the stratosphere and block the sun, that's something that theoretically a single country could do. And so that gets into the ethics of who gets to decide. Who gets to decide when we do this? How do we test it? And who bears that responsibility? Those aren't easy questions.
Certainly not. I am going on this next question that based strictly on popularity, which is that more than one person asked about this topic, which is if like the consequences of ocean currents shifting and or stopping, and Sheila asks, will that basically be Armageddon?
So the day after tomorrow is not a good example of what's going to happen with climate change. That is an example of a tipping point, though. So something like disturbing what we call the Atlantic meridional overturning circulation. We have evidence that circulation is slowing down right now as a consequence of climate change. How close are we, and is it even possible that there could be a really rapid step change? That's an example of a tipping point that we don't really know about.
I'm slightly scared of the ocean gyres and those things stopping, but I don't want to end us on a dire note. So I want to bring it back to what you have said, which is that we're not doomed. We basically just need to push our companies, our politicians, policy leaders to make big changes and collective changes and basically band together and not be so selfish. And hopefully those will be my closing words, because I know we're coming to a close, but I'll kick it to you, Cate, to ask what your closing words would be.
Yeah, I think those are good closing words. I think, we have a choice, and there are a lot of encouraging signs. They're not enough by themselves, but they're a start. And I think I always thought, 10 years ago, if you'd asked me what will the trajectory of climate change look like, I would have said, well, things are going to get fairly scary, and then the world's going to have an oh shit moment, and that's when the action is going to start to happen. And I hope that we may be living in that moment right now, but I think all of us has a responsibility and to seize that moment. So do I have hope? I don't really need hope. I think we make our own hope. So if we want hope, we got to make it ourselves.
Wow, that was amazing. Thank you both. That was an incredible download of information, some of which was very hopeful.
Yes, and that's exactly the way the academies would look at it. I think it would be that same note of hope. And in fact, the last two presidents of the Academy, Ralph Cicerone and now Marcia McNutt, both of whom, study climate, that's their kind of like big day job before they became presidents of the Academy. And I think they would say the exact same thing. And in fact, tomorrow, if you're interested in another round of climate, tomorrow the Academy is they're doing what they call one of their climate conversations. And that will take place tomorrow at 3 p.m. Eastern. I think Sachi will put that link in the chat if you're interested in that. And it's looking at climate security. So we would recommend that from our colleagues at the Climate Communications Initiative. And then Rick, for next week, you probably want to mention our crossover event.
So some of you have seen before our science speed dating programming, and maybe even some of you have seen a very funny show that our sister program at the NAS puts on, Wrong Answers Only. We are going to put them together to do a speed dating with a lot of wrong answers event that will be, I think, a lot of fun, hosted by our speed dating superhost, Ahmed Best. So you'll be getting that invitation, I believe, tomorrow. But please do click an RSVP. We hope you can all tune in for the chat as well.
That's right, because it's going to be 4 scientists and 3 professional comedians. So it should be not as serious as today's event, but lots of fun. So please do sign in, and we hope to see you next week.
Yeah, it'll be just like this week, except like writers from Saturday Night Live and the Late Late Show commenting. So nothing like this week.
Yeah. The same, but totally different.
Yeah. Well, we look forward to seeing you then. Thank you for everybody. Thanks, Kate. By the way, we had over 90 questions today. We got through as many as we could. Obviously, we couldn't get to 90 in the time we had, but thank you for everybody who asked a question. And thank you, Kate, for wading through as best you could. And if we didn't get to your question again, this was my fault.
Bye, everybody.
Bye, everybody. Thank you.